Hello, my name is Dan Hall with Hall Associates, and I'm going to do a short video today about an application for Fluke's Compass for Pressure software interfacing with these two devices here, which are both made by Keysight. I was working on a project recently. I'm actually in the middle of working on it right now, and I needed to interface these two devices to Compass for Pressure. However, these are new devices, newly purchased, and they no longer have an RS-232 interface on them. Typically in Compass we're interfacing with RS-232 or IEEE interface devices, but this newer version of the Keithley or Keysight 34972 does not have RS-232 serial interface anymore. It only has LAN or Ethernet interface on the back. Traditionally in Compass we've used a device like this made by Digi. This is a multi-port RS-232 switching device in order to interface multiple devices into Compass and be able to read signals from them. So the fact that these both had internet or Ethernet or LAN instead posed a little bit of a challenge because I hadn't really interfaced them with Compass before. So I thought I would show you a bit about how I did that, and really to show you that it wasn't that much different than interfacing with serial devices. So in order to interface both of those to my computer, I have a laptop over here connected with Compass, and I'll show you some screenshots of that in a moment. But I needed to use a router, an Ethernet router. So over here I have just a standard Netgear household router that you would use for connecting multiple computers to your home internet. However, I have these two devices connected by Ethernet to the router, but I do not have the router connected to internet service. For our purposes, we don't need internet access, and I know it's really important to mention that because in most companies it's almost impossible to connect instruments like this onto the full network of the company because of security concerns and the possibility of saving certain IP addresses for these devices. So the only purpose in using the router is to use it as a switch that will allow us to communicate to both of these devices, and my computer is also connected into the router. So I've got three connections in here. The blue ones are for these two instruments, and the white one is for my computer. So first I want to show you a couple things about the menus of these instruments. First I'll go into the 34972. What happens when you connect this device to the router is that most routers are set up for something called DHCP, which is Dynamic Host Configuration Protocol. What that means is when you plug this Keysight device in, the router will assign an IP address. An IP address is just like an IEEE address or a COM port for serial communication. It's the address that we're going to send signals to if we want to talk to this device. So I'm going to show you the LAN or Ethernet menu structure for this device so that you can see what its IP address is and how that's sent to it. So let me go into the menus. If I hit up here, LAN interface, and continue to hit this button, it will go through a number of choices. It says that LAN is enabled. It says that it's currently connected to the router. I can reset the LAN if I want. DHCP is enabled on these devices. So both of these support DHCP, or that dynamic IP addressing. And if I hit it again, it will go to the IP address and it'll show me what that IP address is, 192.168.1.5. So I'm going to come over to my computer and I'm going to pull up a program called the Remote Communications Tool, which is inside Compass. The Remote Communications Tool allows me to interface with devices. Usually we've used it for RS-232 and IEEE, but I'm going to attempt to connect to this Keysight device by TCP/IP. So up here in the Interface tab, one of the choices is TCP/IP. Over here, under host name, I'm going to put the IP address that I just saw in the menu structure, which was 192.168.1.5. Host port right here is you get that number from the documentation on these two Keysight devices. So 5025 is listed as the port to use when communicating with the Keysight devices. So with that information set up, if I put in a command over here, I'm going to put star IDN question mark, which is a Skippy command for this to tell me what its name is and what its model number is. If I send that over, and now I can see I'm getting a response that says Agilent 34972, comma, then a number of other numbers in there. I'm not sure what they are. They could be other LAN communication numbers, but we are getting a response back from that device. If I go up to the 53220A, which is the instrument on top, and I look at what its IP address is, let me show you where that is in the menu structure. If I go to Utility and then I/O Configuration, LAN Settings, and then it pulls up a menu here which shows me IP address and all kinds of other connection information. You see also it says DHCP, which is that dynamic host configuration protocol again. The IP address is listed as 192.168.1.2. So if I again go to Compass and I change my IP address to 192.168.1.2 and I send the same IDN question mark command, I should get a response back from this device, and I am getting that response. And you can see it says Agilent Technologies. I guess they haven't changed that over for Keysight yet, but it does say 53220A. So these two devices are communicating. If I send a, for instance, a measure period question mark command, I should get over a measurement of the period of the signal that's connected. You see I'm getting, you might hear a little beep in the background. It's because I don't have any signal connected onto the front port of the 53220, but I am getting a reading back. If I go back to my 34972, go back to IP address 168.1.5, and if I put in this very long command, which is for Rtd Temperature Measurement, and I send that command, and you notice I'm sending it a couple times. I'm getting an interface error, and then all of a sudden it clicks on and I get a reading from the device. So it's about 22 degrees Celsius as measured by a 4-wire PRT that I have connected in the back of the device. For our purposes in an industrial environment, we don't really want to have the IP addresses sent dynamically to these devices every time they're powered on. What will happen is if you power on the top device first and turn the router on, it will assign an IP address to this, which might be the lower number, and then if you power this one on second, it'll give it the next higher address, available IP address. That's not a good situation, because if we want to communicate with it in Compass, we want it to have the same address every time. Just like if we're connected to the same COM port every time, or we have a GPIB IEEE address for each one of these devices, we want it to be the same every time. So I needed to make some changes to this configuration in order to make it more robust, I guess I would say. And I want to show you how I made those changes. So I'm going to go into the menu structures of these instruments again, and I'm going to turn DHCP off. I'm going to put it in what's called static IP addressing. So again, I'm going to go into the LAN interface menu. LAN is enabled. It's currently connected. I'm going to go over to DHCP enabled, and I'm going to change that by rotating this knob to disabled and hit enter. And then for the IP address, I'm going to keep that as the same, 192.168.1.5. And hit enter again. I'm going to basically enter through the rest of these menus, and then it's going to say saving changes. So what I've done is I've turned dynamic addressing off, and I've put a fixed IP address of 192.168.1.5 into this device. And I'm going to go in and do the same for this device here. I'm going to go modify settings. It's currently in remote mode, so I need to back out of that first. LAN settings, modify settings. I'm going to go up to manual DHCP, so it's made that change. It's no longer in dynamic addressing. And for the IP address, I need to go up and change that to some fixed number. Now, what number am I going to change it to? This router sent addresses to these devices before, and they started with 192.168.1, and then there was a number at the very end that varied. So that's the block of addresses that this router is used to interfacing with. So I'm going to change it to be a number different than this number down the bottom, but it still has to be within that. Those first three numbers I'm going to make the same. So in order to do that, I'm going to make some changes here. And just in case I cut this video, I'm going to set it to a fixed number of 192.168.1.2. Okay, it's changed to, oh, no, it isn't. I need to change it to 192.168.1.2. So there's other things I can change, but I don't really need to change anything else. If I back out of these LAN settings now, it's going to say, do you want to cancel changes? I want to say no, because I want to save those changes to the devices. And now I'm going to show you how to change the router so that it will always communicate with these two devices, their fixed IP addresses. So this is the configuration menu for the Netgear router that I have connected. Many of you have probably done this on your home networks. If you go up to www.routerlogin.net and hit enter, it communicates with a web server that's inside the router. And this shows you what the router is currently connected to and allows you to make some changes to different settings in the router. So as you can see here, I'm not connected to the internet. I don't have any internet access in this system right now, but I don't need it for what we're doing. If I connect right now to attached devices, it asks me for the login information. And it pulls up a menu of devices that are attached to the router right now. And as you can see, there's 3 devices right here. We put these fixed IP addresses in, 192.168.1.2 for the key site 53220A and 192.168.1.5 for the 34972A. So those are the IP addresses that are currently connected to it. The other one is my laptop. It's a Dell XPS laptop. So what I want to do now is go into the advanced menu here, and under setup, I want to go down to LAN setup. Now what this shows, this is where the DHCP server setting is. I am going to keep the router as a dynamic host configuration protocol server. However, what I'm going to do is reserve 2 memory locations for the 2 key site devices that I currently have connected. And the fact that I have them connected is going to make it much easier to do this. So down here, there's a section called Address Reservation. And if I hit the Add button, it pulls up another menu that lists the devices that I have connected right now. So if I go over and click in this selection button and then say Add, what it's going to do is add that address reservation to this menu down here. And I want to do the same exact thing for the 34972. which is 192.168.1.5. I'm going to click Add. So now I have two address reservations that this router is going to reserve for this hardware. And even if I plug other computers or other devices into the router, it's going to save those addresses and be looking for them when it powers on. So I'm going to click Apply. And it usually takes about 20 seconds for the firmware changes to be made inside the router. Okay, those changes have been made, they've been applied. So now if we can go back to the basic settings, we can still see the devices that are connected with the router web server. But the important part is now that I can power off both of these devices, all three of these devices, the router and both of these instruments. I can power them back on again, and when I do, those fixed IP addresses are going to be recognized by the router, and we can communicate more robustly with those devices from Compass. So I'm going to do that. Give me a minute to reset this. Okay, we're back. We've cycled power on both of our instruments. We've cycled power on our Netgear router. I'm going to just go through the menu structure to verify that the IP addresses have stayed the same. So if I go into the LAN interface menu, it's enabled, it's connected to the router. DHCP is disabled, which is what I wanted. The IP address is 192.168.1.5. So we've set that fixed. That's always going to be the IP address for this device. And I'm just going to enter through the rest of these, not make any changes. If I go to the top instrument, the 53220, if I go into LAN settings and look up here, the IP address is 192.168.1.2. That's the fixed address that we put in that device. I'm going to hit back. If I then go into Compass and send a *IDN command, which is an identification command to both of these devices, first I'll send it to 192.168.1.2, which should be the 53220. If I send that, I guess you can't see because I've already sent it a few times, but I'm getting a response back with the proper identification. If I change this to address 5 and send this same *IDN, you see I get a response from the 34972A. If I try and send a command to read one of the RTDs, which again is that long command, measure temp RTD, 85 is the alpha value, the resolution, and at channel 201, if I send that, you see I get a response back, 22.17 degrees Celsius. If I send a command to read the period of the signal connected to channel 1, although there is no connection right now to channel 1, then you see I get a response back from that device with a very high period because I don't have anything connected, but I am getting a response back. The beep you hear is because it's outside the range listed for the frequency. So that's a not so quick tutorial on how to connect both of these instruments by Ethernet to Compass for Pressure. All I've used is the remote communication tool, but now I would set up those devices as support devices inside Compass, and I could use those as part of a Compass test. Thank you very much for watching. If you have any questions, please send an email to the email address listed on the video here. Thank you.